to mention, in grade 11, we did a lot of floating triangles. So we had kind of a triangle floating around in space. Sometimes we rotated it around. We did a lot of the scenarios, right? Like a guy standing on a cliff looking down at a boat, or somebody standing on the ground spotting a pretty bird in a tree, and we like determine distances and angles of inclination and depression and such. The big difference that you're going to see in grade 11 is we're going to take that triangle, it's still going to be a right triangle, and we're actually going to anchor it in a Cartesian plane. Okay, we're going to give it some coordinates. Okay, so that's what's coming in the next few days. That's one of the big changes. So you remember from last year, okay, we dealt mostly with right triangles. Okay, we did a little bit. You guys would have seen sine law and cosine law to deal with the special circumstance of how to solve a triangle if it wasn't a right angle. Okay, we're going to continue and just pick up with right triangles. We're interested in that. Okay, so you guys, here you go. A squared plus b squared equals c squared. Pythagorean theorem. You need to know how to do that. Okay. So just a reminder, when we're labeling our triangles, the hypotenuse never changes. It's always the side of the triangle that's opposite your right angle triangle. The other two sides, we're actually going to call them legs. Okay, so if you see the term legs, that's what A and B are going to be called. Okay. Now remember that when you're labeling your right triangle and you're labeling for your opposite and your adjacent, it really depends on what angle that you're looking at. So for example, if I'm looking at angle A, then my opposite is going to be side A. And my adjacent, the ones that's touching, is going to be side B. However, if I change my focus and I'm looking at angle B, right, my opposite and my adjacent are going to flip. So from angle B, my opposite is now side B, and my adjacent is now side A. So just make sure that you're indicating what angle that you're doing when you label your triangle with opposite and adjacent. Okay. So last year you guys would have learned SOHCAHTOA, and you would remember that sine is the same as sine theta. Okay, so these are all ratios. Okay, if I hear someone say sin, that's not how it's pronounced. I will correct you every time. You guys are mathematicians. It's sine. And cos, not cos. It's cos. Or you can say cosine. Tan is fine. Okay, your tangent ratio. Can't mess that one up, I don't think. Okay, just a little minor thing there. All right. So your sine ratio. So it's always sine of an angle. Okay, and sine is opposite over hypotenuse. Your cosine is adjacent over hypotenuse. And your tangent, of course, is your opposite over adjacent. One thing I want you to do right now with your calculator, okay, turn it on. Okay, I want you to hit mode. Okay, every time we reset the calculator, your calculator will default to radian mode. Okay, so remember from last year, especially during your trig unit, you had to make sure that you're in degree mode. So right now, just hit mode, make sure that you're in degree mode. Okay, my guess is that you're probably not, so you'll need to change it to degree mode. If you don't, you'll get absolutely every question wrong. Okay, because your calculator is just in a different mode for the trig functions. Okay, so we are going to be using degree mode. What's new for you guys are the secondary, or what we call reciprocal ratios. Okay. They're not difficult other than that you need a definition and you just need to remember which one goes with which. So this one is called cosecant. Okay, cosecant is simply the reciprocal of sine. Okay, so if you don't have a cosecant button on your calculator. Okay, so if it asks you to solve for the cosecant of 30 degrees, you would first do the sine of 30 degrees and then take the reciprocal of that. Okay, so for example, okay, well, let me just do that. Okay, so I want the cosecant of 60 degrees. Let's just say I'm not going to do exact values right now because we'll get to that in our review in a second. But let's just say, so I'd have to do, this is what I would be doing on my calculator. Okay, I'd be finding the reciprocal of sine. 30 degrees. So you would literally have to go 1 divided by sine 30. Okay? And you're gonna, like in this case, okay, I get negative 1.02. 101. Okay, leave it to the right. No, I'm in radians. If you don't switch it and you just assume, then you're probably not gonna be okay. Let's try that again. For all of you who did it correctly, the answer is 2. Right? Because the sine of 30 degrees is 1/2, so the reciprocal of 1/2 is 2. Right? So that's how we are going to go about solving those. More on that later, but just so you know, so cosecant is the reciprocal of sine, secant is the reciprocal of cos, and cotan is the easiest, is just the reciprocal of tan. So the way that I remember which one goes with which is I just remember that we don't ever like double up on the c's. So if I have a cosecant, it's the reciprocal of sine. Okay, so cosecant's not the reciprocal of cosine. Don't double up on the c's there. So I'm doing a little alliteration. So I just remember that we don't double up. So the beginning part of the reciprocal function is always different than its partner. Okay. Okay, so here's reciprocal again. So now we're going to do just a little bit of math. Okay, so I'm going to remind you what we do when we solve for a side length and how we also solve for an angle measure. I'm going to do 1, you're going to do 2. I think that is their ratio. Okay. So in this case, okay, solving for x, okay, this is what I intend, right, to have good form. The first thing you want to do is label your diagram. Okay, make sure that you're identifying your hypotenuse. This is going to be my opposite. This is going to be my adjacent. Okay, so this way I can see, oh, I need to find x, and I have an opposite and hypotenuse, so that's sine. So I'm going to write down my trig ratio. Okay, I'm going to fill in what I know. Okay, and then I'm going to solve. Now, if you need a refresher on solving, you can use cross multiplication. Okay, so x is going to equal 21 times sine 28. Okay, if you had me last year, I said order matters. Put the 21 first, and then times the sine 28. Because invariably what happens, your calculator, if you've noticed, okay, so quit. Okay, so 21 times sine of 28. Your calculator leaves the bracket open. Now, some of you have recognized that if you just hit enter, it'll do the answer for you. Okay, don't get lazy though. Like, close your bracket, okay, to get the side length. Because what happens is, this is what I saw last year. People would switch to 2, right? Because when you multiply, it doesn't matter which one you do first. But this is what I saw. I saw sine 28, and then they go times 21. And they didn't close the bracket, and then they get the answer wrong. So if you're kind of one of those who maybe forgets to close the bracket, always put the 21 times first, and then you won't have any problems. Okay, because mathematically this is telling the calculator to multiply the angle by 21, not multiplying sine of the angle by 21. Okay, so don't do that. Instead, if you just put the number in front, you should be good. Okay, so this was 9.9 centimeters. Okay, so go ahead and do the next 2. Alright, let's double check your work. Hopefully you discovered that the second one you needed cos. Maybe you should get 7.1 centimeters. And the third one was a tan example. You should get 14.5. Alright. The next example is solving for our angle, our unknown angle. So when we have, I'm just going to label my diagram. So again, opposite, adjacent, hypotenuse. So in this case, I'm interested in cosine is adjacent over hypotenuse. Okay. So remember with this, right here. There's like a function going on here. Okay? So when we want to solve for our unknown angle, or theta, right? The zero with the line through it, that's a Greek theta. If we want to solve for theta, okay, just like when we solve for a regular equation, we want to isolate it. So we have to like undo the operation that is joining those two. So remember that when you put the cos over on the other side, you're going to use your inverse cos button in order to solve for your angle. Okay, so your inverse cos button is just second, and it should be right above your cos button. So you're going to do let me clear that off. Let's start fresh. Inverse cos of 15 divided by 8 divided by 15. Let's get my numbers right. Let's start again. Cos 8 divided by 15. Okay, and you should get 58 degrees. Okay, don't forget that little circle, that little dot for degrees. Okay, I'll make it a little bit bigger for you so you can see it. Okay, your angles always have to have a degrees. Okay, if you just give me 58 without a degrees, okay, you will get marks taken off. Okay, always angles with degrees. Right, now that I've jogged your memory on that one, go for the next two. Okay, so go ahead and take a look. Compare my work with yours, if we all got the right thing. So this was an example of tan, and then the last one was our example of sine. Okay, it's reasonable to give angles to the nearest degree unless it specifies and asks for the nearest 10. Okay? I don't think you'll ever see a degree line for the nearest 100. That's just a little bit too detailed. Right. Okay, so what you're going to see, instead of just for all 3 trig ratios, you might see for all 6 trig ratios. So that means that they want you to do the secondary or the reciprocal ratios as well. Now remember, ratio means fraction. So here, what we need to do first, okay, so we have 2 sides, and we have this unknown side here. We need to solve for that first because, right, 2/3 of our ratios require the hypotenuse. So this is where you'd say, oh yeah, I gotta use that good old Pythagorean theorem in order to solve for x, and then I can go ahead and write the ratios. So just write them as simplified fractions. Okay, that's what I'm looking for here. So first step, you're going to do Pythagorean theorem, 8 squared, 15 squared. Okay, so you're going to have x squared is equal to, okay, when you take the square root of both sides, yes, you're going to have an extraneous root. Yes, you need to circle it, cross out the negative. Okay, because in this type of triangle, we cannot have a negative hypotenuse. Okay, okay, so you're going to have okay, so we have x is equal to 17 and x is equal to 17. So once you have your hypotenuse, then you can just go ahead and, so just pay attention, we have a theta and we have an alpha. So theta, right, this is going to be my opposite. Okay, and my hypotenuse. And then when you do alpha, you're looking at a different angle, so your opposite and your adjacent are going to be changing. Okay, so we should be seeing like opposite 8 over 18, okay, 15 over 17, and you're just double checking to see if these can be reduced at all. Okay, so we're good with those. The reciprocal functions, okay, it really is just writing the reciprocal. So remember, we are at the stage of exact values. Guys, no decimals. At all, ever. Okay, we're all about exact values. And then when you switch to alpha, then this becomes your opposite. This one becomes your adjacent. Okay, so if your diagram gets too messy and you kind of get confused on opposite and adjacent, you can always erase it once you finish, or just choose a different color like I did to kind of keep it firm in your mind if that helps. Okay. Which helps too loud? Go ahead and close the door if you want to hear them banging on their projects. Right, task number 2. Okay, gives us an if sine is 5/6, then what is cos? Okay, are they asking for what is the angle? No. They simply want, like, what is the ratio for cos? Okay, so if we were to draw out a triangle, okay, you pick an angle. It doesn't matter which angle that you choose, whether it's the top or the bottom. I'm just going to choose the bottom because that's kind of what I'm going to do. Okay, so when I label my triangle, okay, so then I know that my opposite is 5 and my hypotenuse is 6. So if it wants cos of theta, I'm going to have to use Pythagorean theorem in order to solve for my missing side. Well, that's one strategy. You can use Pythagorean theorem, or, right, you could, like, I don't want you solving for the angle and then using that again to solve for the side. Like, I just want you to use Pythagorean. Okay, but there are multiple strategies. I just didn't write that one down. Okay, you don't have to be, again, least number of steps. Okay, least amount of opportunities to introduce error. Okay, so if we're going to do, okay, we have 6 squared is equal to 5 squared. Okay, so 36 minus 25. Okay, so we know that the side, again, no, we're good. Okay. Ooh, I gotta spell it right. Okay, so I just called it B. That's fine. So cos theta is then going to be adjacent over hypotenuse. So we could say root 11 over 6. Okay. So as you're going through these, if they give you this kind of situation and they want you to find out the other ratio, before you're done, just double check that there wasn't a radical on the bottom, because if there is, then you're going to rationalize it. Right? That's why we combine radicals and trigonometry, because we had to learn how to rationalize things in order to do the trigonometry. Okay, so go ahead and do the same thing for if cos theta is equal to 4/5. Okay, then what's tan theta going to do? Okay, so again, here's just a reminder, if an irrational number are encountered, something like this, okay, you just have to make sure that you rationalize it. Okay, exact trig ratios, okay, for angle theta, and then determine what the angle is. Okay, and one thing I'm going to, I know you've probably already started solving this one, okay? One thing that I'm going to introduce now, okay, which we'll encounter again in the next couple days, guys, we are going to, okay, we're going to rename the variables that we use in Pythagoras theorem. Okay, because we're going to rename the variables. See, that shouldn't matter, right, that I'm using different variable names. It will help us as we start thinking about what's coming and getting us to think about the Cartesian plane, which have x, y coordinates. We're going to rename the variables. So, from now on, goodbye, a squared plus b squared equals c squared. Hello, x squared plus y squared equals r squared. Okay? This is what we're going to be using. Because we're going to start to attach our triangle to a Cartesian plane. So x is always going to be your horizontal, y is always going to be your vertical, and the r is actually going to stand for a radius. Okay, so the hypotenuse we're now going to call our r value, or our radius. And like, don't worry if you're kind of going, not sure. Like, we haven't got there yet. I haven't drawn the Cartesian plane. I'm just saying that we're going to start renaming this. Okay, so our horizontal is always going to be our x, our vertical is always going to be our y, and our hypotenuse now becomes our r value. Okay, so in this case, right, we always have to use Pythagoras theorem to find missing side lengths. Okay, once you have all the side lengths, then you're tickety-boo to do your trig ratios. Okay, so just a little off to the side here. So and 49, 8. So hopefully you got square root of 58. So then, I'm just going to lift this up a little bit. Okay, so then you can, and it doesn't matter the order. Okay, you can do it sine, cosine, kind of like SOHCAHTOA. That part's fine. Okay. Okay, so we're also, okay, I won't bring that one on me yet. Okay, so sine is going to be my opposite, so 3 over root 58. Okay, don't forget to rationalize. Okay, and then you would just double check to make sure they can't simplify that anymore. Okay, 3 does not go into 58, so this would be our okay, cos, similarly. Cos would be adjacent, so 7 over the hypotenuse. And tan is going to be our opposite over adjacent. And then, okay, just does yours say determine, maybe I took it off. Okay, if it actually, here we go, determine theta. Okay? It does not matter which trig ratio you use, just pick one. Okay? You do not have to reassure yourself and do all three, guys. Okay, just pick one and do one. Okay, so in this case, I'd probably pick one that has nice numbers. My preference would be tan in this example. Right? So if I'm doing that, I choose tan, 3/7, so theta would be the inverse of tan. 27 degrees. Great. Hey guys, the next page is part of your homework. Okay, so I am going to leave that to you for homework. So turn over the page and let's take a look. This is the beginning of our lesson. Yeah. It might be that I just wrote it down. Oh, here, give me a sec. We also you don't want to do that. Oh, and 23 looks better. Totally. Yes. Or you just check Mrs. Branch's back. That would be better. No. You can. Okay. No, tomorrow, hey, don't forget, tomorrow you guys have a quiz. So I have a practice quiz for you to do tonight for your homework. Okay, the homework check that you're going to be handing in is just all your radical homework. Okay, none of the trigonometry, there's no trigonometry on tomorrow's quiz. Okay, it'll be the practice quiz plus 2 questions from the 10 a week. Okay, so if you're wondering if 10 a week is worth to do, there's that's where we take our questions for the quiz. There will be 2 questions right from 10 a week. So there's absolutely no reason to be like, ooh, I forgot that, because you really should have done it recently. Okay, so make sure you can still do switching to vertex form from standard form, that you can still factor in order to solve for your x-intercepts, that you can still do max-min type problems. Okay? Those are things that you will see again and again and again. Great. Let's take a look at the angles in standard position. So here's a Cartesian plane. Okay, it finally comes into view here. Right? So let's label it, make sure that we're all talking about the same thing. So where do we start labeling quadrant lines? You guys remember? Yeah, what do you think? Top right. Top right, absolutely. This is quadrant 1. Okay, then when we label them, we actually go in a counterclockwise position. Okay, the reason for that is because when you guys were little and you first started looking at grids, you learned everything with positive integers. Okay, positive x's, positive y's. We all started life in quadrant 1. And then they started introducing the idea of negative numbers. Right, so we had a number line, positive numbers, and then we introduced this idea that we can have negative numbers. So then we introduced you into quadrant 2. And then we said you can also have positive y values, and that's where quadrant 3 and quadrant 4 came in. Okay? So always stop in the top right, counterclockwise. Alright, label positive x-axis. Okay, we're going to call this, guys, this is our starting point right here. Our x-axis, and it's our 0 degrees. Sorry, I don't like this little dot right here. There we go. Okay, this is our 0 degrees. If we were to go around, say, to get to the top, this just created a very lovely right angle. If I now pointed up to the top. So what would make my y-axis? What degree did I just move? What's a 90-degree angle? What's a right angle? Okay, it's 90! Awesome! You guys are wonderful. Okay? So the top is 90 degrees. Okay? And if I add another 90 degrees, so now I'm over here, yeah, I heard it, then we're going to be at 180. Okay, if I add another 90 degrees, 270, and if I add another 190 degrees, 360. Okay, so you need to know that 0 and 360, we're talking about the same spot. Okay, 360 just means we've come all the way around to the very beginning again. Okay. So what we're going to start seeing is we're going to start seeing angles that are anchored, okay, from our x-axis, and then we might, okay, do this, and we're going to have to figure out what this angle is. Okay. So here we go. In geometry, two rays with a common endpoint form an angle. So you know that the arms, right, those are called your rays. So you have an initial arm where we start, and we're always going to start on the x-axis. Okay, and then we have a terminal arm. It's called terminal because terminal means that it ends. So initial is the start, terminal is the end, and the angle that it makes in between, that's our theta. Okay, the starting position, just set that off. Oh, and we always rotate according to the quadrants. So we always rotate counterclockwise. Okay. And in grade 11, we always rotate counterclockwise. And our angle is positive. Perhaps next year you will also include a rotation that's clockwise. That would be a negative angle. Okay? So we're going to be doing counterclockwise, positive angles. Okay, so we have something that's called standard position. And we need to understand what this is so that we're all like starting from the same point and we're all talking about the exact same thing. So the diagram in group A shows all these angles are in standard position. So you'll notice that we start at the origin. Our initial arm is always on the y-axis. The y-axis. Okay, and then our terminal arm is in some quadrant. Okay, so these all have the same things in common. Okay, and you'll see that, okay, in these examples, okay, which diagram shows, okay, give me a sec. Which diagram shows an angle of 70 degrees in standard position? Okay, so in group A, right, 70 degrees is going to be less than 90. Okay, so this one would be, right, this one would be our 70 degrees. This one can't be 70 degrees because it's more than 90 degrees. And this one for sure is even more than 180 degrees. So we're going to start to get really familiar with taking a look, kind of seeing, like make sure that you have these benchmarks, like 90, 180, 270, 80, and 360. Okay, because if I asked you to draw an angle that's approximately 220 degrees, what quadrant would you be in? Yeah, quadrant 3. Yeah, what's your question?
I was going to ask, can you explain how copying is like
Yeah, so these are non-examples. So group B is like there's this kind of like floating there. Okay, so this would not be a standard position. If your initial arm is not on the x-axis, you are not in standard position. If if it's on the Cartesian plane, but like it's being a weird case, these are non-examples. That's standard position. Okay, so we just need to like see what it is and what it is not. Okay, so this question here, which of these, A, B, or C, is 70 degrees in standard position? So it's not this because our initial arm is like the vertex. Okay, they don't, yeah. So the vertex here is not at the origin. So this is not in standard position. This one, sure it's 70 degrees, but it has to be on the positive x-axis. This is not standard position. So then B is the only one that's actually in standard position. Okay, we start at the origin. Our initial arm is on the positive x-axis. We're all set. Wait, so what I want for you to do is I want you to, again, don't be like super exact, okay, but as best you can, okay. It has to be in the right quadrant, and two, it should be, right, closer to one of the, arms of our Cartesian plane that would make sense. Okay, so for example, 120, okay, okay, I'm going to back up the lesson just a second. I want you to label the quadrants, okay, put all your degrees on, then draw your angle, okay, because those are the details that we're looking for. One, to increase our muscle memory, to make sure that we, are making those connections, that body-mind connection. And that's what good diagrams look like. They're well labeled. Ready to go. So go ahead and put your initial arm from the origin, okay, positive, and then, okay, you're going to be approximately here. Okay, so I would kind of expect you to be a little closer to the 90 than you would be to the 180, right? Because there should be, and maybe I was a little too generous on that, right? There's 30 degrees between between here and 60 degrees between there. So not even in the middle. Right? Same with 309. Okay? You draw as accurately as you can. Okay, and then go ahead for 309 and 217. What is your 309 in? 1, 2, 3, or 4? Okay, it should be in quadrant 4, right? It's between 270 and 360. So I would, you have your initial arm, you have your terminal arm down here. Make sure that you indicate that your angle is all the way from your initial to your terminal. Okay, this is your angle that's equal to 390 degrees. Okay, what quadrant are we going to end up in for 217? Yeah, quadrant 3. Okay. Okay, so that angle right there gets us to 217. Okay, this is just a bit of a summary. Okay, to remind you, angles in standard position. Okay, quadrant 1 is angles anywhere between 0 and 90. 90 and 180, 180 and 270, and so on. We're going to talk about reference angles, and then, okay, I'll give you some time to do some practice questions. All right. So we have something called the standard angle, which we just did. Okay, and now we have a new thing called a reference angle. Okay, you're going to notice that a reference angle is going to have a little subscript of an R. Okay, maybe I'll make that even a bit more obvious. Right, it's a subscript. Okay, so the reference angle is an acute angle. So remember the definition of acute. Acute means less than 90 degrees. Formed between the terminal arm and the x-axis. The reference angle is always positive, okay, and always between 0 and 90. The right triangle that contains the reference angle has one leg on the x-axis, okay, and is known as a reference triangle. So let's plot the following ordered pairs on the grid, and then we're going to draw them with order considered. You'll see the reference triangle, okay? They're just reminding us how to plot, okay, when you have a ordered pair, right? It's x and then y. So we're going to go 3 over 4 up. Okay. So what we're doing is we're actually going to show okay, the x value and the y value as the legs of a triangle. And then we just go from the origin to the actual spot. Okay, if I draw, okay, between the terminal arm and the x-axis, that's right here. This is our reference angle. Okay, between the x-axis and the terminal arm. So in the next one, our dot's going to be at -4, whoops, and 5. Okay, we're going to draw in our reference triangle. Okay, and our reference angle is always between the terminal arm and the x-axis. Okay, and then the final one, we're at 5. Whoops. Okay, so this is at 5, -6. Okay, and our reference angle, okay, is always between the terminal angle and the x-axis. Okay, I'm going over this like a few times simply because some people like see a triangle and they'll, or maybe they won't draw the triangle, they'll just draw the terminal arm. Okay, I never ever want to see the reference angle drawn here. Okay, this is between the terminal arm and the y-axis. Okay, never, ever, ever touching the y-axis. It's always touching the x-axis. It doesn't matter what quadrant you're in, it's always going to be between the terminal arm and the x-axis. Okay, so you're not going to do that. Ever. Right? Okay, that's what a reference angle is. So, let's do a couple of these. So first what you're going to do is you're going to draw, right, the standard angle. Okay, so 243. So what quadrant am I going to be in? Okay, so first label your quadrants. Okay, and then label all your major. Just in case you see the word quadrantal, I have to like practice saying it. Quadrantal angles, that's your 0, 90, 180, 270. Okay, those are your quadrantal angles. Okay, quadrantal. Right, so if we're at 240, we're going to be ending up in quadrant 3. Okay, so we are, okay, this was the initial arm, this was my terminal arm. Okay, this showed the 243 degrees. Okay, so now I want you to draw the reference angle. Okay, so if you need to just go back to the definition, the reference angle is between the terminal arm and the x-axis. Okay, did you draw your reference triangle here? Okay, and this is your, okay, if you can, like you can put your reference angle on the inside. Yeah, I kind of put it on the outside because it gets really small for me, so I might have to like zoom in. Okay, but this is your reference angle here, from the x-axis to the terminal arm. Guys, could you tell me what the value is for the reference angle? Okay.
You could do 243, what are you gonna do? How are you gonna figure it out? Yeah.
Subtract 180.
Okay, so if you wanted to figure out the reference angle, you could do the 243 subtract, right, the closest quadrantal, right, on the x-axis, right, to get a value of 63 degrees.
Okay, it's not asking that. I was just kind of like seeing if you were making some connections there that we could figure out that for every standard angle, it's going to have a reference angle partner. Okay, so right now we are just making sure that we can, like, that we're correctly identifying the reference angle. Okay, and then we're going to get into doing a little bit more of solving what it is. Okay, so if you're feeling good about this, do the next two. Draw the standard angle first, then identify your reference triangle and what your reference angle, just on the diagram where it's going to be.